I'm Anil Kumar sharing with you a video on finding derivatives using quotient rule. Now, many of my subscribers and viewers want to know what kind of pens I use, and that seems to be the most popular question on my YouTube channel. I'd like you to have a good look at my pens, right? So you can actually also read their names from this, right? So these are different kinds of pens I use. But I always go to the market and buy new ones, whichever I like, that I use. There is no specific one which I promote. So this time I got this Pilot pen for the colored things, and for black and blue I'm using Uniball, or this one is T Max. It is with German technology, Atmos technology, whatever, right? So I hope you got a good view of my pens, right? So this is what I use. So I hope that's clear. Okay. Now let's get back to the main topic, and that is to understand how to apply quotient rule and solve questions based on it. Here are, I think, 4 questions. Question number 1. Evaluate derivative and compare domain. So not only evaluate derivatives, you have to compare domain of the function and its derivative. So let me be very specific. Domain of the function and its derivative. Okay. Simple functions to start with. Remember, at times we may apply product rule, right? But in this exercise, we'll stick to quotient rule. Second question is, find the equation of tangent line to the curve at a given point. Then we have, show that there are no tangents to this curve with positive slope. What does that signify? So if there is no tangent with positive slope, that means you get always negative slope, right? So it's always decreasing. Perfect. The last question here is, find the points where the tangent to this curve is horizontal. Horizontal means derivative is 0, right? So you equate it to 0 and find those points. Now when we say find points, you need to give both x and y value, right? So both x and y value. I think you understand this fairly well. Copy these questions, solve yourself, and then look into my solutions. I might do some calculation mistake. Feel free to point them out. Now let's begin. So the very first question which we have here is to find derivative for the function f of x equals to square root of x over x squared plus 1. We'll also talk about domain. That's very important, right? Domain. Clearly, the denominator is always positive, so the restriction is because of the numerator. So we could write domain of this function as x belongs to real numbers, where x is greater than or equal to 0. It's non-negative. Perfect. Since that is not real. Now, applying the rule, and I hope you remember the rule, that is, if I have a function as, let's say, simple terms, let me write f of x as u times v, right? So it could be, oh, we are doing quotient rule. Okay, so it's u over v. So that's the quotient. So then it is the denominator square times derivative of numerator times denominator take away. You can write derivative first, or you could write like this, either way. So that becomes your rule. Correct? So let's apply the rule and find the derivative. So we have derivative of this function as square of the denominator, which is x squared plus 1 whole square. Derivative of numerator. So what is the derivative of this? It is 1 over 2 square root x. I hope by now you are an expert in finding derivatives, so we're not getting into intricacies of how I get this, right? Okay. Times the v, which is x squared plus 1, take away. Now I prefer to write the derivative first. So I prefer to use this formula in this fashion. derivative of this minus derivative of this times u over v square. Simply because the derivatives are simpler than the expression at times. So it is 2x, so I'll write 2x times the function which is square root of x. Doesn't make sense to you. Correct? Now, it's a good idea to simplify these terms. Correct? So let me write this bigger and bolder so that you understand how we simplify this. The denominator is, keep that denominator always in the factored form. Never expand denominator. Now, if you look at the numerator, we could actually take a common denominator of 2 square root x. Do you see that? But on this side, we'll get x squared plus 1 as such. On the other side, gets multiplied, right? So it is minus 2x square root x times 2 square root x. Correct? So now what you can do is, you bring this 2 square root x in the denominator, copy this, which is x squared plus 1 whole square. Combine these terms. So we get x squared plus 1. 2 times 2 is 4, so we get minus 4, and x, and square root x times square root x is again x, correct? So we could write this as x squared plus 1 minus 4x squared over all this, which is 2 square root x times x squared plus 1 whole square, and clearly now we get minus 3x squared. We could write plus 1 first, okay, but it's good to write this first, over all this, which is 2 square root of x times x squared plus 1 whole square. Do you see that? So that is how you could simplify it further. Now that becomes your derivative. What is the domain of your derivative? Let's write that now. So what is the domain of this one? Now we have a restriction in the denominator that it cannot be even equal to 0. So here the domain is that x belongs to real numbers where x is greater than 0. Do you see that? Since we get square root x in the denominator, it cannot be 0. Earlier it could be 0. So there is a change in domain. So when you find functions derivative, domain might change. So that's very important to understand. Okay. So let's take the next one here, where the question is evaluate derivative and compare domains. So a function like this, which is 5x plus 2 over x plus 2, you could apply product rule and do it, right? At times it may be simpler. However, we are practicing quotient rule now. So that's the whole idea. So anyway, let me write domain first for this. So the domain for this function is that x is not equal to minus 2, right? Where x belongs to real numbers. Is that okay? So you could write domain like that. The derivative here is square of the denominator, which is x plus 2 whole square. Derivative of the numerator is 5 times x plus 2 minus. Derivative of this is just 1 times 5x plus 2, right? So we get 5x plus 10 minus 5x minus 2 over x plus 2 whole square. Now that is 5x minus 5x is 0, 10 minus this is 8. So we get 8 over x plus 2 whole square. Well, that's very simple. So in this case, what domain we get? So domain in this case remains same. Do you see that? So say x belongs to real numbers where x is not equal to minus 2. Correct? So sometimes domain will not change. So when you have square root functions or radical functions, domain will change because the radical functions will have a cusp or a corner. So derivative will not have those points. That's the whole idea. Okay. So here we have another question similar to previous one with slight difference. It says find equation of tangent line to the curve at a given point. So first step is of course to find the derivative. So we have y equals to 2 plus x over 2 minus 3x. So the derivative of this function is 2 minus 3x whole square. Derivative of numerator is 1, so we'll just write 2 minus 3x minus derivative of denominator is minus 3 times 2 plus x. Correct? Now we could write this as, so we have 2 minus 3x, let's rewrite. Multiplying, we get plus 3 times 2 is 6 and plus 3x, right? So this 2 negative becomes positive over 2 minus 3x whole square, and this could be written as, so what we have here, minus 3x plus 3x is 0, 6 plus 2 is 8, let me write 8 here, over 2 minus 3x whole square. Okay? We really want to find derivative at x equals to 2. So what we have here is y dash will equate x equals to 2 here. So if I write 2 here, I get 8 over 2 minus 2 times 3 is 6 whole square. Perfect. Now you should also find what is the y value at x equals to 2. We'll do that also, right? Which is 8 over 2 minus 6 is 4. 4 squared is 16. So that is just half. You'll also notice that this derivative is always positive. Do you see that? So in one question we had something like this. So we find that the derivative is always positive. That means function is always increasing. Okay. Now once you find this, we have to find point also. So if I substitute 2, what is the y value? So it is 2 plus 2 over 2 minus 3 times 2, which is 4 over 2 minus 6, which is minus 1. So the point, so what we want to find now is equation of a line whose slope m is half and the point P on it is 2 minus 1. Is it okay? So that is the equation of line we're looking for. So we could write this as y minus y1 equals to m times x minus x1. So it is y minus 1 gives me plus 1. Slope is half. X minus x1 is 2. Cross multiply, so we get 2y plus 2 equals to x minus 2. Bring all the terms together, so we'll take them to the right side. So we can write x minus 2 minus 2y minus 2 equals to 0, or x minus 2y minus 4 equals to 0. So that becomes the equation of the line. Correct? So that is the solution in standard form. So I hope the steps are absolutely clear. You have to find the coordinates of the point to find the equation of line. Now here is the next question based on quotient rule. There was a typing error in the original question, so I just changed it. The question here is, show that there are no tangents to the curve y equals to x square over x square minus x with positive slope. What does this signify? So there was an error. X square minus x should have been in the denominator. So we have the function y equals to x square over x square minus x. We'll apply the quotient rule to find derivatives. So derivative of this function is square of the denominator, x square minus x whole square. Derivative of x square is 2x times x square minus x, take away. Derivative of denominator is 2x minus 1 times x square, right? So that becomes the derivative. Let us simplify this. We get x square minus x whole square. In the numerator, it is 2x cubed minus 2x square. When you open this up, you get minus 2x cubed plus x square, right? And now here we can cancel the cube terms and we are left with the square terms, right? So that gives us, let me rewrite this here. So that gives me minus 2x squared plus x squared as minus x squared over x squared minus x whole square. So that becomes the derivative. Now it says, show that there are no tangents on this curve with positive slope. Well, clearly what we see is the whole thing is positive with a negative sign. So this is always less than 0. We cannot have x is not equal to 0. That is a restriction, right? Because then the denominator will be 0. Perfect. So what we see here is it is negative of everything square, and therefore it is always negative, and we can say that the slope is always negative. That means never positive. Do you see that? Because all these are square terms. All this is square terms. Square means positive with a negative sign. So that is how it could be shown. Right? So let's move on to the next question now, which is find the points where the tangent to this curve is horizontal. Now this is the last question of our practice on quotient rule. When we say horizontal means slope is, that means y dash should be equal to 0. Is that okay? Horizontal is a slope with 0. So okay, so we have this function here, y equals to x squared over 2x plus 1, derivative applying the quotient rule, square of denominator, which is 2x plus 1, derivative of x squared is 2x times 2x plus 1, take away, derivative is 2 for the denominator part times x squared. And that gives you, let's open the bracket, we have 4x squared plus 2x minus 2x squared over, this is square, right? Everything's square. So 2x plus 1 whole square. Now, this could be simplified a bit. Let me write it on the right side. And then we'll equate 0 for y, right? So when we say horizontal tangent, that means slope equals to 0, and therefore I can write 0 for y dash, and then we have 4x squared minus 2x squared is 2x squared plus 2x over 2x plus 1 whole square. Now you can take 2x common. So if I take 2x common, I got x plus 1 over 2x plus 1 whole square. Now to make it 0, either 2x is equals to 0 or x plus 1 equals to 0. 2x equals to 0 gives us x equals to 0. This gives us x equals to minus 1. Now when we say find points, we have to find the y value also. That is very important. So let's find y. So y when x equals to 0 is 0 over 0 plus 1, which is 0. So the point is 0, 0, one of them. The other one, we have to substitute minus 1 here. So we get y equals to minus 1 square over 2 times minus 1 plus 1, which is 1 over minus 2 plus 1, which is minus 1, correct? So we get minus 1 here. So the other point is minus 1, minus 1, correct? So we get our solution. The points where the tangent to this curve is horizontal are 0, 0 and minus 1, minus 1, correct? So I hope with this you understand how to apply quotient rule and find derivatives of the functions. Practice some from your textbook and then take the test which follows. Also look into the chain rule. I hope this helps you to understand the concept. Feel free to share your views, and if you like and subscribe, that'll be great. Thank you, and all the best.